Have you heard of the 2019 smash hit game Among Us? There are tasks for crewmates to complete and lots of ways tasks can go wrong. You may not have noticed, but there are many safety issues within the game. We are going to highlight some of the main safety topics that can be found throughout the game and explain why each of these are critical safety topics to discuss. Always remember to clock in and clock out when starting and ending your shift. When on site, management needs to know who's there and who isn't in case of an emergency.
Here we are showing workers clocking in at the start of their shift. As you can see, they're using their ID cards to swipe in.
Safety logging. Looking over the log from the previous shift to make sure that necessary safety information is communicated effectively. When managing a big process, it is necessary to look over the notes of what the previous operator did whenever you come in to take over their shift. By doing this, you know what the operating conditions are for a given process, so you are not unaware of any changes made. This knowledge is crucial for preventing any possible accidents of miscommunication because the results of this mishap could be fatally and economically devastating. It is important to take note where workers are in certain areas. Here is a scenario where operators are checking to see if there are workers in an area before the area is re-energized.
Before going to work on electrical equipment, it is necessary to check and ensure that the equipment being worked on is not energized. This is done to prevent injuries or death from electrocution due to the equipment still being energized. Here we will see a worker about to enter the electrical area. Before going in, they will attempt lockout tagout the electrical area. They do this incorrectly and fail to properly de-energize the area as a result. They continue to enter the area, not realizing their mistake, and they are now in a very dangerous situation.
One of the potential accidents that can occur when lockout tagout is not performed is an arc flash. An arc flash is a sudden, intense electrical discharge that occurs when an electrical current passes through air between two conductive surfaces. Here you can see that workers that are not wearing the necessary PPE, which is a hard hat, protective clothing, footwear, and gloves, are in a dangerous arc flash zone. Without these protective equipment, someone can be at serious risk of fatal burn injuries, as demonstrated. Due to the lockout tagout not performed and no PPE on, all of the workers had been fatally wounded.
When working with electrical equipment, specifically wires, you must be careful not to expose yourself to flow electricity. You must be sure to de-energize the equipment before handling it. Not doing so could result in a serious injury or fatal incident. Here we see a worker that does not have any of the required PPE on and has not de-energized the area. We see that they have made a mistake when repairing the electrical system, and because of their lack of respect to process safety, unfortunately lose their life.
We will now show how to correctly perform the lockout tagout action for the electrical area. The worker is now going to enter the electrical area. They will reattempt lockout tagout, and this time they will be able to do it properly. The electrical area is now de-energized and safe for entry. The worker will now enter a safe electrical area for their work.
Reactor failure is a common occurrence in the chemical industry. A reactor meltdown may be caused by the loss of coolant, coolant pressure, and flow rate, or might be the result of a critically excursion in which the reactor is operated at a power level that exceeds its design limits. So what are the safety practices that are needed in a reactor failure? Firstly, evacuate the immediate area, then shut down the reactor, then manage the controlled release of radiation, monitor radiation levels, and implement emergency response plans. Safety practices in the event of a reactor failure are designed to minimize the risk. What are the malpractices when a reactor failure happens? Failure to evacuate, delayed or improper shutdown due to panic, inadequate containment of radiation, delayed communication, and especially poor management of emergency response. Malpractices during a reactor failure can worsen the situation and lead to increased risk to people and environment. We will be shortly witnessing a reactor failure and what the unsafe and safe practices are. As you can see, the operators are going to the operating room to do their daily task and start up the reactor for today's shift. Shortly after startup, operating conditions reach a dangerous level due to overheating when you can see the reactor operators started to panic and not follow the proper safety procedure. Although most of the operators handled the situation correctly and did this, although one of them did not follow the correct safety procedures such as shutting down the reactor, activate emergency cooling system, and evacuate. You can see this caused him to die, so it is always very important to follow the proper safety protocols, or this could be you.
An emergency safety meeting is held to help update safety procedures to stop this accident from occurring again. Your coworkers are your family, and you want to make sure that everyone leaves their shift as safely as they entered. Always be on the lookout for potential safety hazards to protect you and your work family. Here are some key takeaways from the safety issues highlighted in the game of Among Us. Number 1, clocking in and out of your shift can help site management verify who is on site at any given time. Number 2, safety logs allow personnel to verify operating conditions and communicate with past shifts, which can help mediate potential risks. Number 3, electrical lockout tagout can contribute to many accidents if not completed properly or at all. Hence, electrical shock or arc flash. Number 4, safety practices and procedures are put in place for a reason, but that does not mean that an accident cannot occur, hence the reactor failure example. Emergency response procedures must be completed to learn from accidents and stop them from occurring a second time.